There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times.
We would like to thank Ed Franks, Hobart Class of 72, for funding and supporting the Franks Lectures. These lectures will be on Thursday and Friday, October 4th and 5th. This year's lecturer is going to be Jimmy Wu. Jimmy Wu graduated with a bachelor's degree from Princeton, then went on to get his PhD at Harvard and postdoc at Stanford. He is now a chemistry professor at Dartmouth since 2007 and has been conducting his research there. Jimmy Wu's research is focused on indole chemistry. The goal of the research is to synthesize biologically active synthetic compounds that will be used to treat uncontrolled cellular replication involved in cancers and other diseases, like AIDS, Alzheimer's, Huntington's, Parkinson's, and ALS.
In our class, we discussed this article, Agawante Chemistry International Edition, 2012, volume 51, from pages 10390 to 10393, and we found some central points that will be mentioned now.
Professor Jimmy Wu is involved in the synthesis of a number of biologically active compounds, the base of which is the indole. This library of compounds that he is synthesizing can be functionalized in a number of different ways, but two of the specific reaction paths that he's focused on have been 4+3 cycloadditions and 3+2 cycloadditions. The 4+3 cycloadditions generally lead to the 7-member ring on the indole, and the 3+2s generally lead to these bridged bicyclic rings. But from there, these compounds can again be functionalized in a number of different ways.
So we're going to look at one of Jimmy Wu's reactions, which is the 4+3 cycloaddition. The reaction begins with a halide, generally a chlorine or a bromine, swinging up with its electrons alpha to the carbonyl, where the carbonyl grabs a metal ion. The other halide then leaves, forming a carbocation intermediate, which also has a dipole with the negatively charged oxygen and the metal. Then we have a pi bond rearrangement, which forms a 7-membered ring. Or, if we look at one of Jimmy Wu's papers, a more exact thing of what he's doing with indoles is shown here. And that leads to biologically active compounds, potentially biologically active compounds like that one.
Let's see why Dr. Jimmy Wu is interested in interdisciplinary research.
If we can understand how these molecules function, perhaps we can use that information and knowledge to develop new therapeutics, cancer therapies, for targeting cancer in a way that's different from what standard therapies can do right now. But in order to do that, we have to be able to make the compounds and synthesize them. And these are incredibly complex molecules from a structural perspective. And so what we're going to have to do is to develop new chemical methodologies and new reactions and then apply them to their syntheses.
Dr. Jimmy Wu's recent work uses 4+3 and 3+2 cycloadditions to make complex indoles, which can be found in water lilies. These compounds have been found central to anti-diabetes research, and the compounds stimulate to release GLP-1 and has the ability to decrease blood sugar levels. He used organic chemistry to synthesize compounds that were later found in biological studies. This work exemplifies interdisciplinary research between organic chemistry and cell biology.
Thanks for watching our video. Remember, the talks are on Thursday and Friday, October 4th and 5th. The talk on October 4th, Thursday, is in the Geneva room at 7 p.m. and is on enabling drug discovery through organic synthesis. The talk on Friday, October 5th, is on targeting the acumulene alkaloids for type 2 diabetes and is designed for biochemistry and chemistry students. Hope to see you there.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times.